interrogation periodically using the mode S transponder. Then the directional antenna receives replies and picks up the bearing of the intruder aircraft. Omnidirectional antenna reports the altitude. Then the TCAS computer unit calculates the range between the two aircrafts and time difference between the interrogation and reply. Then it will map a list of aircrafts that are in the area, same airspace, and is shown on the traffic advisory display. The approximate position is then determined and it will be shown on the nav display. The TCAS computer can pick and negotiate the best avoidance maneuver if a tracked aircraft is a collision threat. So the interactions between the intruder aircraft and your own aircraft equipment. The TCAS-1 does not give resolution advisory at all, and it only gives traffic advisory to mode A, C, or S transponders, TCAS-2, TCAS-1. So on the other hand, TCAS-2 is more sophisticated. It can provide traffic advisory, and it analyzes and predicts the intruder aircraft's flight path, provide the resolution advisory as well. And it is actually designed to give traffic advisory to mode A transponders. It can give mode C or mode S transponders TCAS-1 TCAS-1 traffic advisory and the vertical resolution advisory. So if the intruder aircraft is also equipped with TCAS-2, then the maneuver, which is the vertical resolution advisory, will be coordinated and it will be compatible. So on the right, it's just a graph, a summary of this. So there are ways of interrogation that are called modes. There's mode A, B, C, D, and S. So mode A, it tells us the identity of the aircraft. Mode B is basically the European version of mode A. Mode C tells us the identity and altitude of aircraft. Mode D is an assign. Mode S, which is what we're talking about right now, is an improved system and for replacing mode A and C to relieve the congestion of air traffic control radar beacon system and also to eliminate garble. So TCAS-2 modes. There are 4 modes: the standby mode, the transponder mode, the traffic advisory only mode, automatic mode. So I'll talk about standby mode first. So power is applied to the TCAS, and the mode S transponder does not do any interrogations. And the transponder mode, TCAS is on standby, but the mode S transponder is fully operational. It replies to ground and TCAS interrogations. So the traffic advisory is only mode. Both of them are fully operational, but it broadcasts relevant interrogations, tracks intruder aircraft, and only gives traffic advisory. And lastly, the automatic mode, both of them are fully operational, but it can issue both traffic advisory and resolution advisory. So I'll be talking about the TCAS components, each and every one of them. The TCAS computer unit, so it identifies and resolves threats, tracks intruder and own aircraft, utilizes pressure altitude, radar altitude, and aircraft configuration to control the collision avoidance logic parameters. So on the right, it's just an example of the computer unit. Antenna, so the directional antenna is mounted on top of the aircraft, and the omnidirectional antenna is mounted on the bottom of the aircraft. So the directional antenna actually transmits interrogations on 1030 MHz, and it also separates the replies to lessen garbling. The omnidirectional antenna provides range and altitude data on targets that are below the TCAS aircraft. So on the right is actually a directional antenna. Just a quick recap. The directional antenna radiates greater power in one or more direction for the increased performance, but then the omnidirectional antenna radiates power only in all directions in one plane. So the mode S transponder implements the ATC functions of the existing mode AC transponders. Its selective address capability provides air-to-air information exchange between TCAS-equipped aircraft to ensure mutual resolution advisories. So on the right, it's still another example of the transponder. So mode S and TCAS control panel. It selects and controls all TCAS components, including the TCAS computer unit, mode S transponder, the RA display, and the TA display. So on the right is a control panel example. So the traffic advisory display, it interprets the position of the aircraft relative to the TCAS aircraft. It can either be a dedicated TCAS display or joint use with a radar and traffic display. So on the left, it's a TCAS display integrated onto a nav display. So the resolution advisory display, basically it's a standard vertical speed indicator, and it's altered to indicate the vertical rate that it must be accomplished to maintain safe separation from the intruding. So it contains a segmented red and green eyebrow lights around the vertical speed scale. So when an area is generated, the TCAS computer lights up the appropriate segments. So all the pilot has to do is to fly and keep the BSI needle out of the red segments and comply with the resolution advisory. So oral enunciation. So the TCAS computer generates a synthetic voice to remind the pilot and alert them. So at the time, for example, at the time of traffic advisory, the words traffic, traffic are enunciated and directs the pilot to locate the intruding aircraft on the traffic advisory display. So if equipped with a TCAS tool and there exists a collision threat, a resolution advisory is enunciated using the words climb, climb, climb. So I'm just going to do an example from YouTube.
Traffic, traffic.
So the pilots will be looking for aircraft.
Done. Done.
So it will tell you what to do on the resolution advisory. Okay, that's the end of it. So I'll hand it to Alicia.
Okay, so the approximate size of the monitored airspace around the TCAS equipped airplane. So as Jordan said, there's different types of modes. Standby mode is usually for when you're taxiing, you're on the ground, you know that there's things around you like trees and buildings and other airplanes taxiing, but the standby mode mostly ignore those objects because you know you're on the ground and you don't need TCAS to go off every 5 seconds telling you that there's a tree over there. The TA only mode is used for when you're on final approach or you're at low altitudes. The airspace that it'll monitor is a bit larger, and it's not going to give you a resolution advisory, but it will tell you, hey, you have traffic over here, just so that you're aware and so that you can look out for traffic if it tells you that there's traffic out there. And then there's the automatic for when you're in cruise or at higher altitudes. In this case, the size of the monitored airspace is dependent on the tau values and the altitude. So depending on how high you are, the airspace that is actually the monitored airspace is going to be bigger. And this is going to give you TA and RA for when there's airplanes around you. So the tau values are, as Gabriel and the rest of my group have said, measured in time. They're actually measured in seconds. So it's the kind of time to go distance of another airplane. So if you have an airplane coming at you at say 300 knots, it'll give you a TA if it's 30 seconds away from you, it'll give you the traffic advisory. And then if it's closer, and then it goes to the solution. So this is kind of what I was talking about. So you have the red area, which is the resolution advisory. And for this airplane, let's say he's going 300 knots. So the distance for this specific airplane in this specific situation is going to be 2.1 miles away from you, away from the TCAS. And then the TA is going to be 3.3 miles away. So that correlates to 25 seconds and 40 seconds for tau value. And then it also goes in height as well. So if it's 850 or 1200, there's the TA region and the RA region. So yeah, here's those knots. And then the green section, it'll just kind of be aware of the other airplane and just probably tell you traffic at this time, but not really go telling you what to do. So the rate of closure is also a big factor. So the faster you're going, the sooner that you're gonna get an advisory, whether it's resolution or it's just traffic. So 300 knots, like you saw, it would be 3.3. But the faster you're going, the farther away that they're going to be is when you're going to get that advisory. And this also correlates to the DMOD, as Diego was saying earlier. If your rate of closure is too slow, then the DMOD is going to kick in because it's not going to enter the TA or the RA areas for the monitored airspace. So this is kind of a chart to show this is the distance, so like the rate that they're coming at you, and then the range. So the blue line is the 40-second tau for the tau value, and then the red line is for the 25 seconds, so it's the TA and the RA. And as you can see, the faster you're going, the further away the range is going to be, the TCAS is going to alert you that there's an airplane there.
All right. So I'm going to be doing pilot and ATC interactions with TCAS. So basically, you know what TCAS is, and TCAS is offered in two main types of alerts. That's traffic advisories and resolution advisories. And I'm going to start by talking about traffic advisories. We've already mentioned most of this earlier, but I'm just going to reiterate these main points. Okay, so TAs are displayed in a small screen that looks just like the one pictured here, more or less. They show other transponder for the aircraft in the area, their altitude, and their flight path trend. A TA will be addressed to pilots attempting to make, will be addressed by the pilots trying to make visual contact with the intruding traffic. However, deviations to flight path never actually be made for traffic advisories. They're just alerting you to keep your eyes on them. Okay, this is a chart that shows the four classifications of traffic and how they're displayed in the TCAS system. We've sort of already looked at it. And like the display symbols on the TCAS display are listed there as well. Okay, resolution advisories. Resolution advisories are more serious than TAs. They're displayed on the RA display, which is a small dial that generally displays vertical speeds, as we saw before. Those vertical speeds are listed must be maintained to avoid traffic. The range of vertical speed that needs to be obtained is the green section inside the RA display. Reading in the red section means the aircraft is outside of the desired area, while in the red area, the pilot must still make the changes, and the RA is considered corrective. While in the green, it's considered preventative. RAs are serious events, and pilots should immediately bring their attention towards the RA display whenever alerted to an RA, unlike a TA. That's an RA display, more or less. So again, as mentioned before, if an RA and an ATC clearance oppose one another, the RA takes all authority. The pilot is required to break the ATC clearance and to submit to the demands of the RA. Of course, when able, the pilot should inform ATC of his or her intentions and also alert ATC as to when they are returning to a regular flight path after the RA has been cleared. This is just a chart for standard phraseology that you use for dealing with RAs and how to let ATC know. It probably would have come in handy for those Russian pilots back in the case study we saw. Now, controllers also have responsibilities when it comes to RAs. All these responsibilities are outlined in the controller's handbook. Basically, controllers are not to contradict RAs they know are in effect. However, when an RA is in effect, ATC should alert the pilot of both aircraft involved to possible terrain and obstacle clearances, because RAs don't generally give you instructions to avoid that, so ATC should help out and let you know. However, the ultimate responsibility, that still goes to the pilot, as always. Last major point worth noting is that while an RA is in effect, ATC should make the assumption that other aircraft in the area don't know of the RA and should thus continue to administer instructions to those aircraft. Also, during an RA event, ATC is not required to continue regular separation guidelines. They're allowed to make the adjustments as necessary to ensure the safety of all flights in the area. So those parameters that ATC usually uses might be reduced, and traffic might be passed closer, but it's just to keep everyone safe. And that's more or less it for the controller's responsibilities and the pilot's responsibilities when it comes to TAs and RAs.
And that concludes our presentation on TCAS. Does anybody have any questions?
I may have missed it, but what's like the fail safe for like a TCAS when there's like conflicting traffic? Will it just like never give like similar instructions to both? It will always have one climb and one descent?
Yeah, the TCAS, like the system kind of like they communicate with each other.
Yeah.
So they operate in unison. So like one aircraft will be told to descend, while one aircraft will be told to climb.
So there's like, it never happens where like they accidentally both descend? Like based like
No.
instructions or something?
No, because of the new revision of the 7.1,
Yeah.
they always have one reversal. So like one is always, the one with the mode S, lower mode S transponder code, will always have priority. So if that one is assigned to climb,
Yeah.
the other one with a higher transponder code will be instructed to
And are they issued at like the exact same time, or like they just make
Well,
sure that
they-
one goes and one is the opposite?
yeah.
Okay, alright.
And they'll be constantly monitoring what's happening within what the other aircraft is doing. So
So what will happen if one is has this transponder mode 2 and the second one, and the one is the first version, and the first version doesn't give you the instruction, the second one does. So if somebody has the second one and the other one doesn't get an instruction, only the one with the mode 2 gets the instruction. How would the second one kind of figure out which way he has to go? Because the other one is not getting an instruction. Does that one just fly straight and the other one just
No, the
descend?
second one calculates the climb rate or descent rate of another aircraft first TCAS.
Mhm.
So if it is equipped with TCAS 1 and it's climbing, the second airplane that's equipped with TCAS 2, it can't tell that it's climbing, it can tell the other airplane to descend.
Oh, okay.
People clap.